Mercury, the smallest planet in our solar system and the closest to the Sun, offers a world of captivating contrasts and extremes that have fascinated scientists and authors alike. Its position near the Sun causes it to orbit faster than any other planet, completing a year in just 88 Earth days. Because of this swift orbit, Mercury was named after the Roman god Mercury, the quick-footed messenger, associated with speed and mobility. With its diminutive size of approximately 4,879 kilometers, 3,030 miles, in diameter, it's slightly larger than Earth's moon and dwarfed by other planets. Despite its proximity to the Sun, Mercury is not the hottest planet in our solar system, a distinction that belongs to Venus, whose dense atmosphere traps heat effectively. Mercury's lack of a substantial atmosphere leads to one of its most striking features: drastic temperature fluctuations between day and night. On its sunlit side, surface temperatures soar to 450 degrees Celsius (840 degrees Fahrenheit), while on the shadowed side, temperatures plummet to -170 degrees Celsius (-270 degrees Fahrenheit). This stark contrast of more than 600 degrees Celsius, 1,100 degrees Fahrenheit, gives Mercury the widest temperature variation in our solar system. One unique aspect of Mercury's rotation is that it's tidally locked in a way that creates a strange rhythm between its day and year. A single day on Mercury, from sunrise to sunrise, spans roughly 176 Earth days, almost twice as long as its 88-day year. This phenomenon occurs because of Mercury's 3:2 spin-orbit resonance, meaning it completes 3 rotations on its axis for every 2 orbits around the Sun. If you could stand on Mercury's surface, you would witness a surreal sight. The Sun would appear to move quickly across the sky, pause, move back in the opposite direction briefly, and then resume its original path. This slow rotation and proximity to the Sun create a planetary experience vastly different from Earth's. Mercury's surface is heavily cratered and reminiscent of our Moon, bearing evidence of countless collisions with asteroids and comets. Due to the absence of tectonic activity or weathering, its surface remains largely unchanged over billions of years, preserving a history of impacts. The largest of these is the Caloris Basin, an immense impact crater measuring approximately 1,550 kilometers, 960 miles, across. Formed by a collision with an asteroid, this basin is a landmark feature that underscores Mercury's rough history in our chaotic early solar system. Because Mercury lacks a significant atmosphere to protect it from space debris, it is covered in impact craters of all sizes, and even some towering cliffs, or scarps, that stretch for hundreds of kilometers, likely formed as the planet cooled and contracted early in its history. One of the surprising findings about Mercury is that, despite its proximity to the Sun, water ice exists at its poles. Scientists believe that the floors of some craters at Mercury's poles are permanently shadowed, which protects them from the Sun's heat. This allows these shadowed regions to trap and retain water ice, likely delivered by comets or produced through interactions with the solar wind. Observations from NASA's MESSENGER probe, which orbited Mercury from 2011 to 2015, confirmed the presence of these ice deposits, sparking curiosity about how water-bearing bodies could contribute to water storage on even the hottest planets. Exploration of Mercury has proven challenging due to its position so close to the Sun. The intense solar gravity requires spacecraft to expend considerable energy to enter orbit around Mercury, which is one reason why, to date, only 2 spacecraft, NASA's Mariner 10 and Messenger, have visited. Mariner 10 made 3 flybys in the 1970s, providing the first close-up images and data on Mercury's surface and magnetic field. Messenger, which launched in 2004 and orbited Mercury for over 4 years, mapped the entire planet, studied its composition, and discovered evidence of volcanic activity in its past. A joint mission by the European Space Agency, ESA, and Japan Aerospace Exploration Agency, JAXA, called BepiColombo, launched in 2018 and is expected to reach Mercury in 2025. BepiColombo's mission is to build upon Messenger's findings, focusing on Mercury's magnetic field, interior structure, and surface processes to deepen our understanding of this enigmatic planet. The composition of Mercury adds another layer of intrigue. It is a dense planet, second only to Earth in terms of density. Mercury's density, at 5.4 grams per cubic centimeter, is due largely to its iron-rich core, which makes up an estimated 42% of its volume, a much larger proportion than Earth's core, which accounts for only about 17% of Earth's volume. Theories suggest that early in the solar system's history, Mercury may have had a thicker crust that was later stripped away by a massive impact or by solar forces, leaving a disproportionately large core. Surprisingly, Mercury's core is at least partially molten, which is unexpected for such a small planet. Scientists hypothesize that the presence of lighter elements like sulfur in the core could be preventing it from fully solidifying, though the exact reasons remain a topic of active research. The existence of a molten core is significant because it generates Mercury's magnetic field, which, while weaker than Earth's, is unusual for a small planet without tectonic activity. Mercury's atmosphere, or rather its exosphere, is another of its extraordinary features. Mercury lacks a true atmosphere like Earth's and instead possesses a thin exosphere composed of atoms ejected from its surface by solar wind and micrometeorite impacts. This exosphere contains traces of hydrogen, helium, oxygen, sodium, and potassium, which drift into space due to Mercury's low gravity. Despite this constant escape of particles, the solar wind and radioactive decay continuously replenish the exosphere. While tenuous, Mercury's exosphere plays a significant role in how the planet interacts with space, as the solar wind not only supplies particles but also creates fascinating interactions with Mercury's magnetic field. Mercury's lack of moons is another defining trait. The planet's proximity to the Sun creates a gravitational environment that would make it nearly impossible for a moon to maintain a stable orbit around Mercury. Any satellite would likely be pulled away by the Sun's gravity, or it would impact Mercury's surface due to the gravitational disturbances. This trait, shared by Venus, distinguishes both planets from the other rocky worlds, which possess either a single large moon or a system of smaller moons. In addition to its physical attributes, Mercury has also made a considerable mark on human culture and imagination. Its swift orbit and elusive visibility, best seen near dawn or dusk, have made it a frequent subject in mythology and literature. Ancient civilizations associated the planet with speed and agility, as reflected in its Roman and Greek mythological namesakes, Mercury and Hermes, both gods of travel, communication, and commerce. Writers like Isaac Asimov, C.S. Lewis, and Ray Bradbury have set stories on Mercury, drawn by the planet's extremes of light and dark, heat and cold. In modern media, Mercury has appeared in science fiction movies and television, often as an inhospitable, mysterious world that presents a unique setting for storytelling. One notable example is the animated series Invader Zim, which reimagines Mercury as a colossal spaceship prototype. Its frequent depiction in fiction underscores humanity's fascination with its alien landscape and extreme environment. The dense, rocky composition of Mercury hints at an origin story shaped by high-energy impacts and the young sun's intense heat, leading scientists to believe that studying Mercury further could offer insights into the early solar system. For instance, understanding why Mercury's core is so large could reveal details about planetary formation and evolution. Additionally, its magnetic field offers a rare opportunity to study a magnetic field generated by a mostly metallic, differentiated core, conditions that scientists are still trying to fully understand. Mercury may be one of the least explored planets in our solar system, but the data gathered from the Mariner 10 and Messenger missions, as well as the upcoming BepiColombo mission, continue to reveal its many secrets. Mercury's ancient surface, covered with craters and scarps, tells a story of survival amidst intense solar radiation and bombardment by space debris. Its large core, dynamic exosphere, and extreme temperature fluctuations challenge our understanding of planetology and hint at many unresolved questions. Although it remains inhospitable to human life, Mercury stands as a compelling subject of study that invites us to contemplate what it might be like on a world so close to our Sun yet so different from Earth. In summary, Mercury is a paradoxical world, a planet of extreme temperatures, an oversized molten core, a thin yet dynamic exosphere, and a surface marked by billions of years of impacts. From its rapid orbit and elongated days to its role in human culture, Mercury continues to captivate our imaginations and challenge our understanding of the solar system. As the smallest planet in our cosmic neighborhood, it serves as a reminder that even the tiniest celestial bodies can hold monumental mysteries. Mercury's distinct characteristics and dynamic processes make it an invaluable target for scientific exploration, promising to deepen our knowledge of planetary formation, evolution, and the conditions that govern our solar system's inner worlds.